Hi guys, welcome back to Think Tank. In this video, we're going to talk about triple integrals. Okay, I want to find the volume of a region bounded by two cylinders. Okay, so don't forget to subscribe to my channel. If you have anything that you want to ask, you can let me know in the comment section. Okay, so we're given two cylinders. Okay, this is the first cylinder, x squared plus y squared equals to a squared, and it lies on the z-axis. Okay, the missing variable, that's where the cylinder lies. Here we have another cylinder, x squared plus z squared equals to a squared. This lies on the y-axis. Okay, so we want to show that the volume bounded by these two cylinders is equal to 16a over 3. Okay, so the first thing you have to do, let's try to draw the given problem. So we want to first try to draw this cylinder. Okay, and as we know, it lies on the z-axis. So this is my z-axis, this is my y-axis, and this is my x-axis. Okay, so the first cylinder, okay, that is the first cylinder. Then the second one, which lies on the y-axis, okay, okay. Then performing triple integrals is very easy, but the only problem that we have, we don't have the limits. Okay, so I'll start by the y limits. Okay, from this, if we make y substitute the formula, that means y squared equals a squared minus x squared. Then y equals to plus or minus the square root of a squared minus x squared. Okay, if I do that on this equation, z squared equals to a squared minus x squared. That means z equals to plus or minus the square root of a squared minus x squared. Okay, and now I want to find the x limits. Okay, if we take a closer look on this cylinder is a radius of a, and this cylinder is also a radius of a. So that means the distance from a to a is a, the distance from a to a is a, but this is going to be negative a, and this is going to be positive a. So that means my x limit ranges from negative a to a. Okay, so now can perform a triple integral. Okay, dv. So my a limits, a to negative a, y a squared minus x squared, a squared minus x squared. Okay, then the z limits, okay, dz, dy, dx. Okay, now I want to make things very simple. Okay, let me try to draw this on a line. Okay, let's say this is 0. So from this we know that the lower bound is negative a, the upper bound is a, but we know that this distance is the same as this distance. So that means the distance from a to a is same as 2a. Okay, so I can simplify this by saying a ranges from 0 to a times 2. So that means I can replace this with 2a. Okay, 2a. So if my x ranges from negative a to positive a, is same as saying my x range is from 2, 0 to a. Okay, because this distance is the total distance times 2. So here I can say my x range is from 0 to a, but I have to multiply that distance by 2. So I just multiply this distance by 2, or you can leave it like this. Okay, but this is just trying to make it look simple. Okay, a squared minus x squared negative a squared minus x squared. Okay, then I think if we integrate here with respect to z, since I don't have anything here, that means I have 1. So I'll just add the variable. So that means I have z and put my limits. A squared minus x squared under the square root negative a squared minus a squared under the square root dy dx. Okay, then I want to simplify here, upper bound minus the lower bound. So this is same as saying 2, 0 to a squared minus x squared minus x squared. Okay, then that means I'm going to replace z with a squared minus x squared under the square root. So this is same as saying a squared minus x squared or under the square root minus the lower bound, and the lower bound is negative a squared minus x squared or under the square root. Okay, dy dx. Okay, so negative and negative, this is a positive, and this plus this is same as saying a plus a, it's 2a. So that means this is same as saying 2a0 a squared minus x squared or under the square root a squared minus x squared or under the square root 2 root a squared minus a squared dy dx. Okay, since 2 is a constant, I can pull it out. So 2 times 2 is 4 x squared minus x squared a squared minus x squared. This is negative, the lower bound dy dx. And now I have to integrate. Okay, I've forgotten the expression here. A squared minus x squared under the square root. So let me rewrite it here. 4a0 a squared minus x squared or under the square root negative a squared minus x squared, in the expression a squared minus x squared or under the square root dy dx. Okay, so if I integrate this with respect to y, I'm going to treat this as a constant since I don't have any y variable here. So this is same as saying 4a0 a squared minus x squared under the square root times y, then my limits a squared minus x squared under the square root negative a squared minus x squared dx. Okay, if you look at these limits are the same as these limits. Okay, so if I say upper bound minus lower bound, I'm going to get 2 a squared minus x squared under the square root. So I can save time by just saying 4a0 2 root a squared minus x squared, okay, times the value of this, that is 2 a squared minus x squared times this one, which is root a squared minus x squared dx. Okay, this was my expression. So I'm going to say this times the upper bound of y, this times the lower bound of y, then I'm going to get this. So square root times square root just gets something that is inside the square root. Then I can pull out these two since it's a constant. This refers to 8 is 0, a squared minus x. And now I have to integrate with respect to x. Okay, so this is simple. Treat a as a constant, so I just add x to a squared. Then here I just add 1 to the power of x, then divided by the new power, and this is 8 a squared times x minus x to the power 3 over 3. Then my limits a and 0. Okay, this is equal to 8. Okay, if I replace x with a, here I'm gonna get a squared times a, that is a cubed. Then here a cubed over 3, and if I put 0, the expression will go to 0. So this is equal to 8a cubed minus 8a cubed over 3, and this is equal to 16a cubed over 3. Okay, so we have shown that the volume bound by the two cylinders is equals to, so this is the same concept we use when we want to find the volume bounded by two cylinders as long as they have the same radius. Okay.